Hi everyone, this is Miss Lorette. I'm going to be walking you guys through section 3.1 today. You'll want something to write on and something to write with. For this particular section, we're going to be looking at some very basic concepts regarding inequalities and their graphs. So let's just dive right in. Okay, so the first thing that we're going to take notes on in our notebook are these symbols. And we're going to write what they represent next to them. And when I read these, I'm going to be reading them left to right. At some point, I'm sure everyone in this class has seen symbols that look like this. Maybe you've seen the very last one. It's not one that we're going to be really working with a lot in this chapter. But I always like to include it in these slides just so that students know what it means. Sometimes I actually will write it on an assessment or put it in a comment. But really, we're going to be focusing on these top four. So go ahead and take a moment to copy it all down. Pause the video if you need to. And if I read this left to right, this symbol, if I actually threw some numbers in here, okay, and you don't have to copy these two numbers. I'm just using it as an example. This would read 5 is greater than 2. Okay, so that's what this symbol represents. It means greater than. If you've learned about inequalities in the past, maybe your teacher even described it as being kind of like a little Pac-Man mouth or an alligator mouth where it wants to eat the bigger number. So in that example that I just wrote, I'll write it off to the side here. 5 is greater than 2. The Pac-Man mouth is eating the 5 because it's the bigger number. So the value that is facing this open part will be the bigger one, and the value that's facing this little pointed part, that's always going to be the smaller value. Well, if this symbol up here means greater than, you could probably use logic to make an educated guess that this symbol means less than. So let me include an example off to the side here. I can actually rewrite this example, but instead of saying 5 is greater than 2, I can do 2 is less than. I can just copy that symbol. 2 is less than 5. These next two symbols look like the greater than and less than symbol, but they have a bar underneath. So this bar underneath actually represents or equal to. So this symbol, which looks like the greater than symbol, means greater than or equal to. So there's a couple different ways that you can use this symbol. You can use it to represent a value that's bigger than another. So I could say 5 is greater than or equal to 2. Or I can show that two numbers are actually equal. Only one of those two statements has to be true, right? Just because 5 and 2 aren't equal doesn't make this inequality false. It's still true because 5 is greater than 2. So since one of those statements is true, this entire inequality is still a valid, true inequality. This inequality is still true, even though 5 isn't greater than 5. This bar underneath says that they could be equal. Since 5 is equal to 5, this is also a valid inequality, okay? And likewise, this symbol, which looks like the less than symbol, means less than or equal, whoops, don't know what happened there, equal to. So again, there's two ways that you can use this symbol. You can show that one number is less than another number, or you can show that one number is equal to itself. Either way is a valid way of using that symbol. And then, like I mentioned, this last symbol, we're not really going to use it in chapter 3, but I always like to include it. It looks like an equal sign with a slash through it. It quite literally means not equal. Not equal. So you might, say that 5 does not equal 2, or you might even say that 1 plus 1, which we know equals 2, does not equal 3. right? So you may have seen me, if you're a student in my class, you may have seen me write a comment that uses this symbol where you were doing arithmetic and you said, this plus this equals this, or this times this equals this, and you got the wrong answer. I may have used this symbol. Okay, that's all it means. All right, so once you've got all of that written down in your notes, let's jump to the next slide. And let's take a look at these two examples. So I'm using 5 and 2 again. This just kind of demonstrates that you can write inequalities in two different ways and it'll mean the same thing, but you got to be really careful when you're reordering the way that you write an inequality. If you're flipping the sides that the values are on, right? So when you're flipping an inequality, you need to make sure that that inequality symbol is flipped as well. When we're dealing with an equation, if I said x equals 3, that would be the same thing as 3 equals x, right? I don't need to make an adjustment with that equal sign. It's still going to be an equal sign. But when we're looking at an inequality, that symbol, you need to make sure that it's facing the correct way. So if my first inequality read 5 is greater than 2, and I flipped the side that the 2 and the 5 are on, I need to flip the direction of the inequality as well so that it still reads 5 is greater than 2, or in other words, 2 is less than 5. If I don't flip it, whoops, let's see what's going to happen. If I if I left that inequality symbol the same, it would read 2 is greater than 5, right? Well, the first inequality was true. 5 is definitely greater than 2. But if I don't flip that symbol, but I flip the numbers, is it still true? Is 2 greater than 5? And of course, the answer is no. This is not correct. So this is why we always want to make sure that we're being really careful with rewriting an inequality. You just want to make sure that the symbol is facing the correct way. All right, so the first thing that we're going to do, take a moment to write all of this in your notebook. Pause the video if need be. You do need all of this information down. We're going to determine solutions to inequalities. And all you're going to do here is perform a check. So at this point, we've done checks for equations. We're going to do the same thing for an inequality. It says, consider the numbers 17, 12, and -3, which are solutions to 49 is greater than -2 plus 3n. Okay, so here's the thing. For an equation, there's only one answer, right? So if you're doing a check and you find the correct answer, you don't really need to check all the other numbers. For an inequality, you have a range of answers, right? If I told you that high school students are, well, I'll do a more general example. If I told you that this individual, Alex, was greater than 10 years old, what could be a valid age for Alex? Well, he could be 10 and a half, he could be 11, he could be 20, he could be 31. There's a lot of answers that would work for that inequality, right? So if I test these values and I find that 17 is a solution, that doesn't mean that that's going to be my only solution. I have to do checks for all the values to see which ones are actual answers. 17 could be a solution. 17 and 12 could both be solutions, or all three of the values could be valid solutions. So we're going to start our check by testing the value of 17. And the way that I do that is wherever I see an n, I'm going to replace it with this number. Okay, so I'm going to write my inequality exactly the same way, but wherever I see an n, I'm going to replace it with 17. And remember, 3n is the same thing as 3 times n. So I'm doing 3 times 17. At this point, if you're in my class, I'm letting my students use calculators. If you are with another teacher who is not letting you use a calculator, you'll want to stack the numbers. At this point, when we're doing a check, we're not solving, we're using PEMDAS, order of operations, to evaluate, which says multiply before we add and subtract. So that's why I'm multiplying first. I have to do this part first. So if you're not using a calculator, you want to stack the numbers and multiply. That's going to give me 21, so I write the 1 and carry the 2. 3 times 1 is 3 plus 2 more gives me 5. So now I've got 49 is greater than negative 2 plus 51. So notice I didn't try and add 2 to both sides. I didn't try and divide both sides by 3. Those are inverse operations. When we're doing a check, which is what we're doing when we're testing solutions, we're doing a check. You're replacing the letter with a number and using order of operations on the side that has operations. So right now, we should only be looking at the right-hand side of our inequality. Also, make sure that you're not inadvertently changing this to an equal sign. At this point in the game, we've done so many equations. A common mistake I see students making is they'll accidentally change this symbol to an equal sign. Remember, this is an inequality, so we want to make sure we're copying down that greater than symbol every single time. The last operation I need to do here is I need to do negative 2 plus 51. Whoops, I want to change that back to the other color here. Be consistent. Negative 2 plus 51 is going to give me 49. So you may be thinking, oh, I'm getting the same number on both sides. My check is working out. Therefore, this number is a solution. Pump the brakes. It's not an equation. It's an inequality. We have to read what it says and ask ourselves, is it true? This reads 49 is greater than 49. Is that true? Is 49 greater than itself? And the answer, of course, is no, it's not greater than 49. If there was a bar underneath, then it would be true because that bar would mean they could be equal. But since this symbol does not have a bar, this is strictly saying that 49 is greater than 49, and that's my only choice. And that's not true. 49 is not greater than 49, so 17 is not a solution. Okay, 17 is not a solution. I still have to check the other two values here. Let me see if I can just move that part. It's not going to let me move just this part here. So I'm going to do my best to squeeze in all of the other checks here, and I'll just use this bottom space if I need to calculate anything else. All right, so we're going to test 12 next. And again, wherever I see that in, I'm going to replace it with 12. So I'm going to test the number 12. So my inequality is going to read 49 is greater than negative 2 plus 3 times 12. Again, I'm going to have to multiply first since I multiply before I add and subtract. 3 times 2, I can do that in my head. That's going to give me 36. I'm going to bring down everything else that I haven't done anything with yet, paying careful attention not to change that to an equal sign. And then I'm going to do negative 2 plus 36. Signs are different. I take their difference and get a positive 34. So again, just because both sides of my inequality does not have the same number does not immediately make this not a solution. We have to read what the inequality says. This says 49 is greater than 34. Well, that's true. So 12 is a solution. Okay, and just because 12 is a solution does not mean that we get to stop. We have to test if negative 3 is also a solution because it's possible to have more than one solution when you're doing an inequality. So now I'm going to test the value of negative 3. Again, wherever I see that variable, I'm going to replace it with negative 3. So I'm going to rewrite my inequality here. 49 is greater than negative 2 plus 3 times negative 3. Following order of operations, I'm going to multiply first. Again, I can do that in my head. Negative 2 just comes down. 3 times negative 3 gives me a negative 9. Next thing I do is I subtract. But because their signs are the same, I'm actually going to add the two numbers together and just match the negative sign. 9 plus 2 is going to give me 11, and it's going to be a negative. And now I need to read the inequality to see if it's true. 49 is greater than negative 11. Well, right off the bat, that's automatically true. 49 is positive and 11 is negative. all positives are greater than negatives. So -3 is also a solution. So 2 out of the 3 numbers were solutions. So make sure that when you guys are doing problems like this, you're checking all of the values and you are doing a check. You're not solving. We're not to solving yet. That's going to be in the next lesson. Okay, let's take a look at another example here. I'm going to pause the video and let you try this one. When you unpause, you should see which numbers are solutions and which ones are not. Okay, so here is what I'm getting when I tested all of the values. I'm getting that -1 is not a solution. When I substitute -1 for that variable y, you're going to have a -7 times a -1, which gives you a positive. Adding these two numbers together gives you 20. 20 is not less than 6, and 20 is not equal to 6. Neither of those statements are true, so it's not a solution. Plugging in 0, I got that it's also not a solution. -7 times 0 gave me 0. 13 minus 0 gave me 13. 13 is not less than 6, and it is also not equal, so not a solution. When I plugged in 1, I got that it is a solution. -7 times 1 gives me a -7. Subtract that from 13 and you get 6. 6 is not less than 6, but it is equal, which is what this bar underneath means. So since one of those statements is true, 1 is a solution. It works. 3 is also a solution. When I plug it in, I get -21 when I multiply and -8 when I subtract. -8 is less than 6. They're not equal, but it is less than. So again, since one of those statements is true, it works. Okay, so let's talk about graphing. Graphing is something that we're going to be doing throughout the entire chapter 3. So it's definitely something that you're going to want to get in your notebooks. You may even want to draw an example of a number line in your notes, just as a reminder of what a number line looks like. So a few features for a number line. You've got a line with arrows on the ends. It's important that you include those arrows because numbers don't end. We can just keep counting forever and ever. So that's what the arrows mean. Numbers will keep going for forever in the negative direction and for forever in the positive direction. When we label numbers, if we're labeling negatives, just remember they are labeled backwards. So the numbers that look bigger are actually the numbers that are smaller and will be on the left. And then the numbers that look bigger will actually be on the right. And then for positives, they just flow numerically in order from left to right. When we're graphing inequalities, and some of this might not make sense until we get to the examples where we graph, but I just want you guys to write this information down so you have it ready to reference. When you're graphing inequalities, you're going to put some sort of circle above the number that you're graphing or directly on the number line. I usually have my kids do it above so it's a little more clear. And that circle is either going to be an open circle or it's going to be a closed circle that we color in. And the way that you determine what type of circle to use will be determined based off of your inequality symbol. If you have a symbol that does not have a bar, you're going to do an open circle. If you have a symbol that does have a bar, which means or equal, you're going to do a closed. The way that I kind of describe it to my students is this bar means that you want the number to count. So think about when you guys take a standardized exam and you're filling in those bubble sheets, those scantrons. When you want your answer to count, you color in that circle. Same idea here. This bar means we want that number to count. We color in the circle, okay? The next thing that we're going to need to do is we're going to need to shade our number line in the correct direction. We're either going to shade the values to the left or the values to the right. Again, I typically do it above my number line so it's very clear, but you can certainly do it on top so long as it's very clear where your shading is. This part tends to be a little tricky for some students. You always want to make sure that you're reading the inequalities starting with the variable. So read from the variable first. Read from the variable. Okay, so if your variable is some sort of value that is greater than or equal to, so for example, X is greater than a number. Okay, the open part is facing your variable. Or like this, if you had your variable on the right side and that open part was still facing the variable, you're going to shade to the right. Because think about it. If you had the inequality x is greater than 5, that's telling me that all the solutions for that inequality have to be greater than 5. Well, if I look at this number line, where are all the numbers that are greater than 5? To the right of it. So I would shade to the right to include those values. If you had that your variable was less than some sort of number, or again, less than or equal, it doesn't matter if it's got the bar underneath or not, but the pointy part is facing your variable, you're going to shade to the left. Again, I can use that same number as an example. If we had the inequality x is less than 5, that's telling me all of my solutions have to be less than 5. Where are all the numbers that are less than 5? There are all of these to the left, so we would shade left. So some of this might not make sense right now, but when we start graphing, I'm hoping that over time it'll start to click. Pretty sure they have examples like this on Khan Academy. I'm not 100% sure, but it might be something that you guys want to do if you're in my class for some extra credit. Okay, so I'm going to do some examples with you. When we graph an inequality, we're going to start by drawing a number line. And when I do my number lines, I tell my students, you got to do at least 3 values. If you're in a class with a different student, they may specify that you have to do more or less. Make sure that you're checking with your teacher specifically if they have specific requirements that are different from mine. But I require 3 specific tick marks. The number that goes in the middle is the number in the inequality. So I'm going to put 2. And then I'm just going to choose a number that I know exists to the left and I know exists to the right. 1 and 3 are probably the most logical choices. Again, you may have a teacher that specifies that you have to choose specific values where they may say they have to be equidistant and they have to be exactly 1 value bigger and smaller. I actually don't care. I tell my students, so long as the value you're putting on the left is smaller, and so long as the value you're putting on the right is bigger, I don't care what numbers you use, and I don't care if they're equidistant. You could have put negative 500 on the left and then positive 1 million on the right. Those values are definitely smaller and bigger than 2 respectively. I don't care. I'm just going to go with 1 and 3 because that seems like the easiest, most logical choice. So my number line is ready. Now I got to actually graph this inequality. Well, first thing I need to do is determine what type of circle do I need to put above the 2. Well, I look at my symbol. If there's a bar underneath, which this one does have, I want that 2 to count. That means x is greater than or equal to 2. Or equal means you want to color in the circle. The next thing I need to do is I need to either shade my number line to the right or I need to shade my number line to the left. So to do that, I look at the inequality, but I start from the variable. I cannot stress that enough. You have to start from the variable in order to determine your shading. This says x is greater than 2. Greater than or equal to 2, because the open mouth part, if you looked at this like it was a little Pac-Man mouth, it's eating the x, so that means x is the bigger number, so x is greater than 2. Well, all the values that are greater than 2 are to the right, so I'm going to shade my number line to the right. And again, you can do it on the number line or you could do it above. Here I can change color, so I'm just going to do it on top. Normally, though, with a pencil, I do it above. All right, let's take a look at number 2. Again, I'm going to get my number line ready. I'm going to put a minimum of 3 tick marks. The number in the inequality is what I'm going to put in the center. And then I'm going to choose a number that is smaller and bigger. Now be careful, this is negative. Negative numbers flow backwards on a number line. So the number that's actually smaller than -3 would be a -4. Again, you could choose other values that you know are definitely smaller. You could have chosen -5, -10, -100, so long as it's a number that is smaller, unless your teacher is giving you specific directions. And then I'm going to choose a number that is bigger. Well, -2 is a nice choice because I know that that number is definitely bigger. Now I need to determine, what type of circle do I put above this -3? Do I do an open circle or a closed circle? Look at the inequality and see if it has a bar underneath or not. This does not have a bar, which means I don't want to include the -3 as part of my solution, so I'm going to leave that circle open. You only color it in when there's a bar. Now I need to figure out which way to shade. Again, we start reading from the variable. This says x is less than -3 because that pointy part is facing the variable. So that means this is the smaller value. Well, if x is less than -3, all the numbers that are less than -3 are going to be to the left. So that's where I shade. Last one, I draw my number line, 3 tick marks, -1 goes in the center. They're negative, so they flow backwards, so I'm going to choose -2 as my smaller number and 0 as my bigger number. I'm going to look at the type of symbol I have to determine what type of circle I use. It has a bar underneath, so above the -1, I'm going to draw a circle and I'm going to color it in. Now I look at my inequality from the variable first, and I read it from the variable. This says r is less than or equal to -1. So all the values that are less than -1 are going to be found on the left. So I shade left. So make sure that you've got these examples in your notes. When you're ready to move to the next slide, go ahead and give these a try, and as usual, I'll pause the video and then we'll compare. Okay, here's what you should have gotten for your answers. You should have put -5 in the middle of your number line for number 1, a number that's smaller on the left, bigger on the right. These are negatives, so they're going to flow backwards. Close circle above the -5, shade left since A is less than or equal to that number. Number 2, same thing with my number line. The numbers flow backwards. -1 is going to go somewhere in the middle. Open circle since there's no bar underneath our inequality. Shade left since B is less than -1. Always start with the variable first. Number 3, these numbers are going to flow the way that we would expect them to for positives. They're just going to flow numerically, smaller to larger as I read it left to right. Closed circle above the 6 since there's a bar underneath that symbol, and then I shade right because this reads V is greater than or equal to 6. Okay, so hopefully those weren't too hard. Let's take a look at the other type of question that you could get. So instead of graphing and graphing based off of an inequality, I'm giving you the graph and you have to write the inequality that goes along with it. It's kind of the same idea where you're going to need to look at the circle and where the shading is and correlate that to the right type of inequality symbol. And the first thing that I like to do is I like to identify where that circle is. What number is that circle sitting above on that number line? That's the number that you want to write in your inequality. I tend to write a variable first. It doesn't matter which variable you choose, so I'm just going to choose x. And I usually leave some space and write the number to the right. Then I determine which way do I want my symbol to face. If the shading is going to the left, you want some sort of less than symbol, okay? If the shading goes to the right, you want some sort of greater than symbol, okay? So since this shading is going to the left, I want the x to be less than -2 since all these numbers are less than -2. And then last but not least, I determine if I need a bar under that symbol. Well, if I have an open circle, that means I don't want the bar underneath. Okay, so I leave it just like that. Here's my final answer for number 1. I'm going to do the same thing for number 2. I'm going to choose a variable. Again, it doesn't matter which variable you choose. And then off to the side, I'm going to leave some space, and off to the side, I'm going to put the number that circle is sitting above. This shading is going to the right. So I want my variable to be greater than 2 because all of these numbers are greater than 2. Last thing I need to determine, do I want the bar underneath? I look at the circle. If it's closed, I want the bar underneath. So I throw a bar underneath my symbol, and that's it. That's my answer. All right, so here are a couple for you to try. As usual, I'm going to pause the video, and then we're going to compare our answers. Okay, so here's what you should have gotten. Now keep in mind, there are different ways to write your answers. You don't have to put the variable on the left like I'm doing. Okay, some students like to put their variable on the right. If you do that, just make sure that the inequality is still facing the correct direction. So if I put the -5 on the left and the x on the right, or whatever variable you chose, I would still want to make sure that the symbol I'm using has a bar underneath, and I would still want to show that the variable is less than the number. So I want that pointy part facing the variable here. So just keep that in mind. And again, it doesn't matter which variable you choose. For the first one, you should have had some variable is less than or equal to -5. For number 2, you should have had some variable is greater than 3. No bar for the second one. Okay, so the last thing that we're going to cover in this particular lesson are real-world problems. Real-world problems are kind of like word problems, but we're not really solving anything yet. We're just going to write an inequality that represents the situation. So we still want to define a variable, kind of how we do when we're doing word problems for equations. Your variable is going to be the thing that is the value that can kind of vary. So it says Mrs. Nito's class can hold at most 30 students. Well, think about it. What's the thing that can vary here? Does her class have to hold exactly 30 students? Or can it be a number less than that? Her class can actually hold less than 30. It can be that she has 30 students in her class, but it could vary. Maybe she has 10 students in a class. Maybe she has 15 students, right? So that's what I'm going to define my variable as. I'm going to say x is the number of students. And now I'm going to use this variable to write some sort of inequality where x is the value on one side, 30 is the value on the other side, and then I need to choose some sort of inequality symbol to go in between. So I need to think about this logically. It says that her class can hold at most 30 students. So you may want to start thinking of some examples here. We know that if it can hold at most 30 students, her class can have equal to 30 students, right? She can have exactly 30 students in that class. So I know that whatever symbol I choose, it's got to have that bar underneath. Well, if her class can hold at most 30 students, can her roster exceed 30? Can she have 31 students? And the answer, of course, is no. This is the maximum number of students that she can have in her class. So it can be equal to 30. It can be less than 30. X can be less than 30, but it cannot be greater than. So here is my final answer for number 1. I've defined a variable and I've written an inequality. Here's one for you to try. I'm going to encourage you to pause the video here, and then when you unpause, I'll just walk you through. Okay, hopefully you've given that a go. It says that for number 2, to earn an A, a student must earn at least a 90%. Okay, at least a 90%. So think about the thing that can vary here. Well, the thing that can vary is the percent that you earn. So that's going to be how you define your variable. So X is the percent earned. Okay, so I know I'm going to have my variable. I know I'm going to have 90 on the other side. And again, you can write it the other way. You can put the 90 first and the X after. You just want to make sure that you're facing that inequality symbol appropriately. And it says to earn an A, a student must earn at least a 90%. So think about what that phrase means. If you earn a 90%, did you get an A? If you earned exactly equal to 90%, did you get an A? And the answer is yes. It says I can earn at least a 90. That includes the 90. So I want the bar underneath my inequality symbol. Then I need to think about whether the X value, my variable, my percent earned, can be less than that or greater than that. If I earn a percent less than 90, if X is less than 90, so say an 89%, is that still an A? And the answer is no, you would have a B plus. So the percent can't be less than 90, but it can be greater than 90, right? If you earned a 91, that's still an A. If you earned a 95, that's still an A. If you earned a 100%, that is still an A. So I want my variable to be greater than or equal to this 90. Okay, I'm just gonna double check to see if we've got any slides after this. Nope, that was the last one. So this wraps up our lesson for today. I hope that you found it helpful, and I will see you guys next time. Take care.